In today's lesson, we are going to be looking at the sine ratio. Now, this is going to be very similar to the tangent ratio lesson that we previously did. And the idea is just that it's going to be pretty much the same thing, right? The idea with right angle trig is that you're going to go through the same processes and same kind of steps to solving for a side or an angle. The only difference is that you're using a different ratio. So you're going to see something, or you're going to see a lesson that is very, very similar to everything that we've done previously, just with sine instead of tan. So again, trigonometry is the study of relationships between sides and angles and triangles. Right, we're going to be focusing on a right angle triangle, or a triangle with 90 degrees in it, and there are three ratios. We've already looked at tangent, and today we're going to look at the sine ratio. So again, with right angle trig, we need to label our three sides, right? So we should remember this from the last one, right? We have our right angle here. Let me just change the size of the pen. So we have our right angle in the bottom corner. Across from our right angle is our hypotenuse. Our hypotenuse, it is also the longest side of the triangle, but like I said before, depending on how the triangle is rotated or how it's oriented, how it looks, it might not be as clear which side is the longest, right? So that's why always going across from the 90-degree angle, that should be labeled or that should be clear to see. We do have, or we need to have a reference angle to find our other two sides. Our opposite and adjacent, we said before, are based on reference angle. I'm going to switch it up this time for this one. I'm going to put my reference angle up at the top. Right, so this is theta. We've mentioned before, this is theta. This is just references an unknown angle. And we're going to use that angle to help us label our other sides. Now, the adjacent and opposite, again, you could just kind of look at the terms in that, or in what the words mean. Adjacent means beside, opposite means it could mean across from. Now, in this case, right, I would always suggest to label the opposite first. Right? That one tends to be the easier one, right, because it's opposite of my angle. So opposite of my angle comes straight across. Use a different color for this one. Opposite my angle comes straight across to the opposite side. And then lastly, that means my adjacent. Adjacent means beside. So that is the side beside my angle, my reference angle. Or it's the last remaining side. Now, one thing to note, right? It differs, right? That's what we talked about. That if you go back to the previous lesson, right? We had the reference angle in the bottom corner down here, but when we labeled our sides, the opposite was actually over here and the adjacent was on the other side. So those can switch. It all depends on what angle you're dealing with. And that's why we base them off of the reference angle and not specifically the right angle. So with sine is a different ratio of sides, right? Tan was opposite over adjacent. Sine is opposite over hypotenuse. Again, theta represents our angle. The opposite and the hypotenuse, these are representing side lengths. So again, very similar to the tangent ratio, just a different set of sides, but same formula, same idea. So we're going to look through a couple of examples similar to the last lesson, finding side lengths. Now we should be a little bit more comfortable now because we should be more familiar with the process, right? So the steps are still going to be the same. We want to label our sides. So we have our hypotenuse, we have our reference angle, so we have our opposite and then our adjacent. Because I'm dealing with the opposite and the hypotenuse, that tells me that I'm going to be using sine. So I'm going to write out my ratio. I'm going to fill in my information. So I know the angle is 38. I know my opposite is 18, and my hypotenuse is x. So now again, this looks very similar to the tangent ratio questions that we did in the previous lesson. What did we do when the missing piece was on the bottom? Well, we brought it up and we multiplied. Or sorry, we didn't bring it up and multiplied, sorry. We brought it up and we ended up with x times sine 38 equals 18. Now to get x by itself, we moved the sine 38 over to the other side, recognizing that sine 38 just meant a value. So we have 18 divided by sine 38. And this we can do on our calculator. 18 divided by sine 38. And we end up with 29.2. So that is our missing side length. If you didn't get that, remember what I said before, make sure your calculator is in degree mode. Right? If you have your calculator and it's not in degree mode, you are going to get a different answer. So please make sure that you are comfortable with the calculator. Yes, the phone calculators can do this, but make sure you're comfortable using an actual calculator that you'll have to use on a test or a quiz or an assignment. For B, again, same idea. We were trying to find a missing side. Let's label everything. I have my hypotenuse across from the 90-degree angle. I have my opposite across from my reference angle here, and I have my adjacent that's beside it. The only sides that have information are opposite and hypotenuse. So I'm going to be using sine. And again, we'll talk more about how to recognize when to use one or the other in a future lesson. But again, opposite and hypotenuse, and our lesson is focusing on the sine ratio specifically. I'm going to fill in my information. Sine of 18 is equal to x over 19. Now in this one, the missing piece is on top. So what did we do last time in the previous lesson with tan? We brought the x up, or the value up, and we multiplied. So 19 times sine 18 equals x. This one's a little bit easier to solve because it's going to just be a calculation. 19 times sine 18, and we should get 5.9. We'll say rounded. So 5.9. Again, if you're not getting that answer, make sure your calculator is in degree mode. In some cases, you may have to maybe put brackets around the 18 in sine or close it, right? So there might be some things that you have to do just to make sure that your calculator does things in the correct order. Two more examples. Again, very similar to our last lesson. Let's label our sides: hypotenuse, opposite based off the reference angle, adjacent. Sine theta equals opposite over hypotenuse. Sine 42 equals 13 over x. Now again, now we've done a couple examples like this already. We can kind of simplify it, which we said switch and divide. So x switches with the sine 42, so we have 13 divided by sine 42. We get x is equal to 19.4. So again, when the missing piece is on the bottom, we said switch and divide. Again, it's not going to be the full steps, right? It's kind of a simplified version to that, but it's just supposed to be that kind of those terms to help you remember the steps. Next one, again, labeling. So we have our hypotenuse, we have our opposite based off of the reference angle, our adjacent. We're dealing with the opposite and hypotenuse, which I forgot to highlight in the last one. You don't have to highlight it, but I like to highlight it because it makes the sides that we're dealing with stick out. And when we're not told specifically what ratio to use, it helps to know what sides we're dealing with. So again, sine theta equals opposite over hypotenuse. Sine 46 is equal to x over 15. Similar to the last one, when missing pieces on top, we bring the bottom value up and we multiply. So 15 times sine 46 equals x. Straight multiplication, you can enter this right into your calculator and get 10.8 equals x. If you're looking at your answers and you're saying, and you want to see, does this make sense? What you could do is compare it to the hypotenuse, right? If you have a value and you're looking, or if you have a side length or a leg and you have the hypotenuse and you want to see, does your answer make sense? Is it smaller? Right? Remember, the hypotenuse is the longest side. So any other side should be smaller. In this case, 10 is smaller than 15, which is the hypotenuse. So again, first glance, that does make sense. For the other one, for C, we're trying to find the hypotenuse. So we found an answer of 19.4. Is that larger than my opposite? It is. It's larger than 13. So at least at first glance, okay, my values make sense. So then again, with the missing piece on top, we bring up and multiply. With finding angles, it's going to be the exact same thing. We still need to use the inverse of our trig function. So in this case, it's not the inverse of tan, it's the inverse of sine, or sine -1. So again, you're going to be pressing second or shift on your calculator, not to get tan, but then sine to get the inverse. Right, so again, make sure you can find those buttons on your calculator, because if we do sine theta equals 7/14, right, I can convert that to a decimal if we want, or if you want. Right, so I can make this sine theta equals 0.5 if it's easier for you to work with decimals. If it's a long decimal though, like we talked about in class, I would say try to keep a few decimal places. You don't want to round early. So if I want to find theta, then theta is the inverse of sine. So I move sine over, or you can think of an operation of canceling it out, of 0.5. This is just on your calculator. So we get an angle of 30 degrees. Sine theta equals 0.25. Again, same idea. Theta is going to equal sine -1 of 0.25. Theta equals, punching it in on our calculator, 14, let's say 14 degrees. This one could, kind of on the cusp, it could go either way. Let's say 14 degrees. And for our last one, theta equals sine -1 of 0.4321. So inverse of sine, 0.4321. We get 25.6, or we can say 26 degrees for our angle. Again, very similar to what we did with the tangent ratio, except instead of tan, we're using sine. Let's just do two examples where we're trying to find the angle from a triangle. So in this case, we have our unknown angle. That is going to be our reference angle. We still have 90 degrees, so we can label our hypotenuse. We can label our opposite because it's across from our reference angle, right, or theta, and then we have our adjacent. So again, we're dealing with our opposite and our hypotenuse, which is sine. Sine theta equals O/H. Sine theta equals 23/25. I can bring the sine over. Sine -1, or the inverse of sine, is 23/25. And again, you could divide 23 divided by 25 to get a value or a decimal number and then plug it in. Or you can, if you're comfortable with your calculator, you can do it all at once. You should get 67 degrees. For B, again, same idea. We have our reference angle, our unknown. We can label our sides. Opposite over hypotenuse, right? Those are the two sides we're dealing with, opposite hypotenuse. So sine, again, sine theta equals O/H. Sine of an unknown angle is equal to 4/5. Theta equals sine -1. 4/5, right? Bring that sine function over, that sine ratio, or the sine over becomes the inverse. So sine -1 of 4 divided by 5, or 0.8. And we get an angle of 53 degrees. So again, if you felt like, hey, this looked very familiar, it should, right? The exact same processes or methods to solving that we use for the tangent ratio are what we're using here with the sine ratio. The only difference is what sides we're dealing with. Here we're dealing with opposite and hypotenuse, and the ratio that we're using, which in this case is sine instead of tan. Right, so again, the idea is that with right angle trig is that it's very, very similar in terms of the methods between the three different ratios. Right, that doesn't change. The only thing that changes, like we said, is the ratio. We have one more to go in our next lesson, which is cosine. And if you guess that it's going to be very similar, you're right. It's going to be the exact same layout, the exact same kind of setup, just with different triangles, different angles, and different sides that are being given to us.